Hi, we're back in the BMC boat shop, and we're going to work on some scarf joints and some gluing and mixing epoxy. So you recall we did a stress test the other day on one of our scarf joints. The students made up, it's right here, they made it up before the school shutdown. And it's still glued solidly, and where this fur broke was right here. And it's a long sloping joint, made its own scarf joint. It broke along the grain lines. So we're going to glue this busted joint back together with epoxy. And we also made some other joints. 45-degree butt joint. This is just a butt joint. Very little surface area. See how small that is compared to that surface area? That's why this is strong and this is weak. We're going to glue this together, and we're going to glue this butt joint together too. This is just end to end with a piece of wood. So, very small surface area. And I'd actually like you to do these calculations. 1/2 inch thick times 1.5 inch tall. What is that surface area compared to this surface area? There's the numbers. And later, a little later, we'll take a look at this other surface area, because this is a scarf joint. I don't think it'll break there. But this is the experiment and the test, and we'll see. So we're going to start by mixing epoxy. And that's right here. We're using a bunch of tools. We have some rubber gloves on to keep the epoxy off our hands. We have a bunch of different clamps. This is a C clamp. You all know why it's called a C clamp, right? Looks like the letter C. We'll be using a pipe clamp. It's called a pipe clamp because the body of it's a pipe. We have carpenter's clamp. Some people call these parallel clamps. I've been calling them carpenter clamps. Some people call them Jorgensen clamps because Jorgensen Company makes them. This is a bar clamp. These are one of my favorites. They're real heavy because the body of the clamp's a big steel bar. This slides open and closed, and clamps tight. Bar clamp. We'll be using all these tools. Here's the epoxy, and we're ready to mix. So, epoxy, as you may or may not know, our students will know, other people watching this video may not, it's a two-part adhesive. There's a resin and a hardener, and there's a strict ratio. There's that word again, ratio, just like the scarf joint ratio. It's 2 parts of the resin to 1 part of the hardener. And these pumps are metered pumps, and they mix out the right amount. So I'll do 1 pump of the resin into this mixing cup, and 1 pump of the hardener, the catalyst, into the mixing cup. So this pump was metered out twice as much material as this pump, keeping the ratio proper. Do one more pump here. Here's the catalyst. This is a special type of reaction, and it's a special type of glue. When these two mix, and they have to be mixed thoroughly, they start a chemical reaction, and it actually gives off heat. It's called an exothermic reaction. So one important part of this epoxy, this adhesive, is a thorough mixing. You have to scrape the bottom and scrape the sides, and make sure 100% of the catalyst is mixed with 100% of the resin. Scrape the sides off, scrape the bottom off. To do that, I made a flat surface on our tongue depressor, popsicle stick, so I could scrape every surface thoroughly. This resin will soak into the wood. This adhesive, epoxy adhesive, will soak into the wood, and then if there's any gaps, there shouldn't be, on this project, they'll fill the gaps too. This adhesive has a certain viscosity. It's a bit runny, and you can see that. And we mix it up to make the viscosity that we need. Viscosity means how runny is it. So this is running like maple syrup. A lot of times we describe it like food. Maple syrup. It's almost watery. But we can thicken it with different adhesives, different additives, to for different qualities that we want. We can mix it up real thick, like peanut butter, if we need to epoxy something on the ceiling so it doesn't just drip on us. Thick or thin can be for a high density epoxy for a real solid project that needs a ton of strength, or just adhesive epoxy, sticking things together. So we're going to put some of these additives in here. This is an adhesive additive. This is an adhesive additive that helps glue things together, and another thickening additive that makes it a little bit wood colored. It's not real super high structural kind of adhesive. And this is still really runny. So we're going to paint this on these joints, and it'll let it soak into the wood for a while. Painting it on these joints, it's called wet out. I'm going to wet these out. So on this simple butt joint, we're just painting it on the end grain, wetting out the end grain, and that'll soak in. Both sides of the joint. Take off the C-clamp, wet this out. We're going to wet out all these joints first. This is the 45-degree butt joint. The other side of the 45-degree butt joint. Just taking a little paintbrush, spreading it around. That'll go there. We're wetting it out so it soaks in. It'll soak into these joints. Fill all the little tiny microscopic holes and soak into the wood and soak into the wood grain. And that keeps it strong. Makes it strong. Make sure we have it thoroughly coated. This other side of this joint. This is clamped down to the table already. You see I have some plastic on the table to help with the cleanup. I'm trying not to make a huge mess, or any mess at all, really. So this is soaking in. We're going to thicken this up a little bit more so it's not so runny with the same additive. Put a little in. Stir it up. Stirring sort of slow so it stays down in the cup. And this is getting a lot thicker. Thick it up even more. Remember when we first mixed this out of the containers, it was pretty clear. And now it's looking more, you could call it wood colored. Sort of a medium brown. And it's nowhere near as drippy and runny. Like I said, if we put a lot more additive in, this could be like peanut butter, and we could put it on a vertical surface and it wouldn't run and drip and droop. It would just stay put. Now we don't need to put this on both sides of the joint. You can just be happy with it on one side of the joint, and that would be enough. I'm going to use my paintbrush again. Put some on the paintbrush. That's it. So now we have a bit of an epoxy sandwich. We have thin on both sides, and then the thickened epoxy in the middle. And put it together, and we'll see some squeeze out. That's good. We want to see squeeze out. Means we put enough on. We'll take a C-clamp, put a piece of plywood on there so we're not scraping up the wood. Protect the wood. Get this clamp down solidly. Slide this into it. That's it. Clamp this down. We'll let this sit overnight. Now, by tomorrow morning, this epoxy will be hard. It'll get harder for a week. But tomorrow it'll be hard enough. I'm going to get this clamp in place loosely and then slide these two pieces together real tight. I'm pushing this way. Let me go over here. I'll push, make sure it's lined up. Line it up a little so it won't move. That's it. That'll glue together. And the idea is we'll try to break this. We'll break this whole piece. It's about 7 feet long, and this will be the first one to break. I'm predicting. It's an experiment. I'm not really sure, but we'll see. We'll come back and clean all this up later, all this squeeze out later. Put a little more thickened epoxy on this joint, like that. You can see how it's not running too much. Now, put this in here. Oh boy, I'm gonna have to flip this over. That's all right, I'm gonna do that first. Take off that cabinet clamp. I guess I'm gonna do that. Do that later. Do these one at a time. Push this down and squeeze. There's the squeeze out. We'll check the alignment. Feels real good. Can feel with my fingers how it's flush. The alignment's flush on the sides. Grab one of these little pieces of plywood so the clamp doesn't scrape up the wood. It doesn't matter. This is a scrap wood and this is an experiment, but this is what we do instead of making clamp marks on your piece. Now this clamp is loose. Make sure it's tight down that way. Tighten this up. The C clamp. There we go. All right. Next step, we'll just repeat. Get some of this thickened epoxy. This is more applicable, the thickened epoxy, in this rough, just a break, because it's uneven. It's all these other joints I cut with a saw, and I cut with the saw, they're real smooth. This joint was just a break where this Douglas fir broke, and there might be gaps in here, but they'll be filled with epoxy. All right. Turn this over. This will be harder to align too. So I'd like it to be straight. If we do this really well, it'd be really hard to see this joint. That's good. I think I'll put the bar clamp on this one. There we go. I guess I don't have a little piece of wood for this one. It's all right. Down, make sure I'm, oh, no I'm not. I'm gonna loosen it. I gotta move this a little bit. That's all right. That's where we want to be. Tighten the clamp. All right. Now, we tighten the clamps, and the pieces are tight together, and some of this glue might ooze out. So a lot of times we tighten these clamps up again, a little bit more. Now we're going to clean this up. We'll get a putty knife and a rag. In this case, we might use a paper towel and scrape up the excess glue. And check our alignment one more time. Get most of it off of here with the putty knife, and the rest of it off with a rag. Now, if this was a critical spot in a nice table or on the chines of the porcupine, what we would do is this would all be masked off. So there wouldn't be glue spreading around these joints. And we'd have masking tape on there, and we'd have some damp rags with vinegar or isopropyl alcohol, and we'd clean them up like that. I think I could get, oh, look at this. See, as I push down, more glue squeezes out. I'm going to have to put another clamp on there and squeeze it down like that. That'll be a better joint. We'll do that. I could use the cabinet clamp, but it's wood, and I don't want to epoxy the clamp to this. I'm going to find another, we'll use this bar clamp. That'll do it. It won't stick to it. Put it there. Back it up a little bit. There we go. See that squeeze out? It's good. Now, I mentioned this is an experiment. We want to see where this will break next time. I'm predicting it won't break here. I think this will be as strong as these scarf joints that we designed and engineered and already did, that also didn't break. So, C-clamps, pipe clamp, bar clamp. What kind of clamp would you call this? Now for 30-some years, called it a spring clamp because there's a spring in there. But a student one day said, Mr. Eisenberg, I think that's an A-clamp. That must be an A-clamp. And I've been calling them A-clamps ever since because, look, looks like an A. So, we'll let this sit overnight. Maybe tomorrow or Monday at the earliest, we'll be breaking these, and we'll see what breaks easiest and what's the strongest. Meanwhile, we're continuing to work on porcupine. Notice the transom, all the trim's on now. All the transom trim's on. We have some holes to plug. Cut some 3/8 plugs and epoxy them into those holes. And we'll align the grain. We'll try to pick the same color of epoxy. We'll use epoxy, we'll pick the same color of wood and try to align the grain so the plugs on the fasteners don't stick out so much visually. And we'll continue this. I wish you were here helping. So stay tuned and check the web page and answer all the questions. Thanks.